Hello everyone, and welcome to today's chem lesson. Today we are going to talk a little bit more about electrons and their place in the atom, and the way that they are arranged in the electron shells where they live. Now, to refresh just a little bit, when we last looked at the model of the atom, we looked at the shell model, which had protons and neutrons in the nucleus, and electrons in these shells out here. The nucleus with a positive charge because of the positive charge of the proton. Neutron having no charge, neutral, so the only type of charge in the nucleus is a positive charge. And all of the electrons are out here in these shells. Now, these shells are not physical things. It's not like a bookshelf that exists if there's no books on it, right? These are imaginary boundaries, right? These are like the borders between states. There's no line that you pass through when you go from North Dakota to South Dakota, right? You just pass through, and now you're in a different place. There's no wall that surrounds North Dakota. Right? There's no wall that surrounds New York that lets you know, like, oh, hey, I passed this wall. I'm in New York now. Right? You just look at the signposts that are there, and you're like, okay, I guess I passed some sort of boundary. These shells are not real things, right? They're not bookshelves. They're more like these borders between states. They are paths that the electrons will follow as they loop around the nucleus. So if we look at a picture, something like this, we see nucleus here in the middle and 3 of our shells. There are a total of 7 possible shells. And I drew this in a specific way here. Right? We got our first shell, our second shell, our third shell, 4, 5, 6, 7. These are concentric circles. Right? Each one is bigger than the one that came before it. So the first shell is the smallest circle, and the 7th shell is the biggest circle. The difference between the first and the second and the third and the fourth are pretty big differences. But as soon as you get to the 5th, 6th, 7th, these are pretty much the same size. There's really small differences between this last couple of shells. And what we're going to talk about today a little bit is how many electrons can fit in each of these shells. Right? Each shell can only hold a limited number of electrons. And when we look at the way electrons kind of settle into these shells, they settle in from the innermost shells and then move outwards. Right? They want to be as close to the nucleus as they possibly can be, and so they will fill the spots close to the nucleus before taking the back rows here, 5, 6, 7, 8. Or 4, 5, 6, 7. So let's look at that in a little bit more detail. Again, we've got 1, 2, 3, 4, 5, 6, 7 shells. Each shell can hold a maximum number of electrons. The first shell, being the smallest, can hold a maximum of 2 electrons. Second shell, being bigger, can hold 8 electrons. Third can hold 18 electrons. Then, like I said before, the 4th, 5th, 6th, and 7th shells are all pretty much the same size. The 4th through the 7th shell all hold the same number of electrons. They can all hold 32 electrons total. Alright, so 32 for the 4th, 32 for the 5th, 32 for the 6th, and 32 for the 7th. we will see pretty often the shell configuration drawn up this way, right? Nucleus followed by these small semicircle pieces that are meant to represent the shells, right? You don't have to draw the whole circle going around every time because it takes up a bunch of space. And will represent how many electrons are in there with numbers underneath. Something like this would be the shell configuration of an element. You could also see it written this way, without any picture accompanying it, to say 2 electrons in the first shell, 8 electrons in the second shell, 18 in the third shell, and 6 in the fourth shell. Notice how we filled the first, filled the second, filled the third, and then put some in the fourth. When we put electrons in, they want to be as close to the nucleus as possible, so they will fill those seats close to the nucleus and then move outward. Let's try some practice. When I give you an element like this, there are 2 really important things for you to check. The number in the bottom left-hand corner, which is the atomic number, the number of protons, and then up here the charge, which is the number of protons minus electrons. Right, so this combination of numbers will let you know how many electrons you have. If there is a charge of 0, you know that the number of protons and number of electrons are equal. So since all of these have no charge, we have 4 electrons for beryllium, 14 for silicon, and 33 for arsenic. What I want you to do is take a minute and see if you can give me the electron configurations of these things. Can you appropriately allocate these electrons? Remember, you want to fill one shell before moving on to the next. So, for beryllium, we have 4 electrons that need to get placed. We'll put 2 in the first shell, and then 2 in the second shell, filling up one shell before moving on to the next. For silicon, we have 14. 2 in the first shell, 8 in the second, 4 in the third. For arsenic, we have 33. 2 in the first shell, 8 in the second, 18 in the third, and 5 in the fourth. And again, we're filling up the first shell before moving on to any other. Filling up the first and the second before moving on to the third. You can leave these extra shells as zeros, or erase them and not include them, or some combination. If you want to put one extra shell with a 0 in it, that's fine. Now, electron configurations are given to us on the periodic table. And so if we pull up the periodic table and look at these three elements that we just saw. Right, let's do beryllium first. Beryllium has an electron configuration of 2, 2. Right, matching what we got from our own practice problem. Silicon, which is over here, matches up with our 284. And arsenic matches our 28185. Alright, filling one shell before moving on to the next. But if you remember from when we talked previously, we talked about how the shell model is not the most accurate model of the atom. The quantum mechanical model is the most accurate model of the atom. The periodic table that we see on our reference table uses electron configurations that come off of the quantum mechanical model. And so that means when you look at something like cobalt, which I just highlighted, it goes 2, 8, 15, 2, which would normally be 2, 8, 17, right? Because we could fit up to 18 electrons in the third shell. The periodic table is correct. Right? The quantum mechanical model is correct. And the reason for this is that Bohr's model of the atom, Bohr's picture of the atom, is not perfect. He drew his with perfect concentric circles. But in reality, the shells overlap. And so there are parts of the second shell that are closer to the nucleus than parts of the first shell. And that weird overlap is what causes the shells not to be filled in the order you expect every single time. So, what you see on the periodic table is always the correct electron configuration, even if it is a little bit off from what you would expect. Now, let's do a couple of practice problems. Here, which one of these shell configurations is correctly filled in? A on the left or B on the right? The correct answer here is choice A. If we have our 3 shells here and we want to fill them in, we want to fill the first shell, we want to put as many as we can in the second shell before moving on to the third. Right? We're not going to just partially fill the second and then move on to the third. We're going to totally fill, put as many as we can in the second shell before we put any in the third shell. So A is the right answer here. What about this one? A on the left, B on the right. Which one of these is correctly filled in? Here, the correct answer is also A. This time, though, it's because the first shell can only hold a maximum of 2 electrons. 3 electrons is way too many to put into the first shell. You cannot ever overfill a shell. Right? The maximum for the first shell is 2, maximum for the second is 8, then 18, and then 32. Never ever will you be able to overfill a shell. Last one. Again, A on the left, B on the right. Which one of these is correctly filled in? Here, the correct answer is choice B. With 10 electrons, you want to fill the first shell with 2, and then fill the second shell with 8, and then you have none left to put into the third shell. Here on the left, this electron should be in the second shell. Right, we can fit 2 and then 8 like we have here. This is called an excited state. When one electron is out of place, and is going to be the entire focus of our discussion next time. But for now, I'm going to transition us over to our Zoom meeting for questions, comments, concerns, and attendance, and I will see you there.